Okay, so this video is going to help with approximating, and approximations in calculus are when you want to use the tangent line to kind of help you out. You have a difficult problem and you're not able to solve it unless you have a calculator nearby. So the tangent line is a way to make it a little bit easier to estimate an answer. So here's what I'm going to talk about. Let's say I have a function called g of x, and it's just kind of a graph that's made up, and I'm curious about where the root is. The root is the x-intercept, so I'm curious, where is this root? Well, to figure that out, all you have to do is take the function g of x and set it equal to 0. Wherever g of x equals 0 is where the roots are. So usually that's what we do, like in algebra. If I say find the roots, you'll take the equation for the curve and set it equal to 0 and you'll solve. But let's say g of x is some equation that's a little too difficult to solve. Like, I'm going to make this up. G of x equals 3 plus 2x squared minus x to the third power. That's what this graph is. So if I had to set all of that equal to 0, I would have 3 plus 2x squared minus x cubed to the x to the third power equals 0. And I'd want to solve for x. It's going to be a really difficult problem to solve for x. If I have the use of my calculator, then sure, I can do all of this. But without the calculator, really difficult to solve this one. So instead of trying to figure out the answer, I'm going to write a little note here. Too difficult. I'm not saying it's impossible, but I'm saying it's just kind of hard to do. So instead, my plan is to use the tangent line. What I'm going to do is I'm going to pick a point really close to here, somewhere like up around here. And I'm going to draw a straight tangent line. So let's grab a ruler for a moment and draw a straight line that kind of has to match the slope of the curve. So it's going to look something like this. Like that. And I'm going to call it t of x for tangent. This is the tangent line called t of x. Check out what happens. Right here, when you get really, really close to the x-axis, you have the root, and then the tangent line has a root. And they're really close together. I mean, if you zoomed in right here, they're so close together, they're almost the same. So really, t of x and g of x are pretty similar. Farther away I go, not the same story, but really close to here, they're really close to each other. So what I'm going to do is say, well, this is too difficult to solve. But I bet you I could take the t of x function, the tangent line, set it equal to 0, and it might be really easy to solve. So that's my plan. That's what I'm going to do. So there's 3 steps to this problem. Once you kind of know what it's asking, you're going to go through deriving and writing an equation. So step 1, you want to derive the function. So step 1 is derive. And since g of x was equal to 3 plus 2x squared minus x cubed, that's the thing we're going to be working off of. So I'm going to derive this thing. I'm going to use the power rule. G prime of x equals, the derivative of 3 goes away, 2x squared becomes 4x minus 3x squared. And then what I need is, once I derive it, I'm going to find the slope. So derive and find slope is all part of step 1. So you know when you have a tangent line, how we always say in class you want a point and a slope? We're going to figure out the slope in a minute here, but I don't know the point. That was kind of an issue. So I need to go back up to the graph. I need more information. I need to know, where is this point at? So let's say this point is at x equals 2. Right here is at x equals 2 for the point. Okay, so if I know where the point is, then I can plug the point into my derivative to get the slope. G prime of 2 equals 4 times 2 minus 3 times 2 squared. And that's going to be 8 minus 3 times 4 is 12, so I'm going to get negative 4. So G prime of 2 equals negative 4. Okay, cool, so there's my slope. Comes from my derivative. Okay, that's step 1. Now that we got that figured out, I'm going to move ahead to the next step. So I'll break this off here, and I'll do step 2. And for step number 2, I'm going to get a tangent line. I'm going to do my whole point and slope routine and figure out the equation of the tangent line. So step number 2, we want an equation for tangent line. So we know how to do this. We've done this in class a lot. You get the two important pieces. You get the point, which is at 2 comma something, and the slope, and in this case slope is equal to -4 from our derivative. So we just need to figure out the rest of the point, and to figure out the rest of the point you take 2 and you plug it back into the original equation. So remember you had g of x up here. G of x equals 3 plus 2x squared minus x cubed. You're going to plug 2 back into that. So I'll do that, I'm going to do that in a different color here. G of 2 equals 3 plus 2 times 2 squared minus 2 to the 3rd power. I'm going to plug that in. And then I'll know what the rest of my point is. So if I plug all that in, I think you end up getting 11. Let's see, 4 times 2 is 8. 8, oh no, that's not right. 4 times 2 is 8 plus 3 is 11, but then 2 cubed is 8, so 11 minus 8 is 3. So I'm thinking the point is at 3. That sounds better. 2 and 3. Okay, so we got my point. We got 2, 3, and we got a slope. So now I write my equation. Y minus 3 equals the slope -4 times x minus 2. And in class, we've done all these problems where we get a tangent line. We usually just stop right here and we circle this as our answer. But now I need a little bit more. So I'm going to go to the next step here. So next step, we're going to go maybe down below here, step 3. And we're going to rearrange the equation. I know this is a good answer normally, but I want t of x. I want the tangent line equation to be like a y equals. So I'm actually going to take this equation and multiply the -4 and do the distributive property and get y minus 3 equals -4x plus 8. -4 times -2 is an 8. Add the 3 over, and y equals -4x plus 11. There's my tangent line equation. So I'm going to rename this t of x equals -4x plus 11. That's good. So here is my tangent line. So now backtrack a little bit back to the start when we had a graph. Remember we were looking at this graph earlier, and the whole entire goal of this problem was to find the root. So we just found out that t of x equals -4x plus 11. It has a -4 slope. It's going down 4 over 1. That makes a lot of sense. So what I'm going to do is say, okay, I wanted to set it equal to 0 and solve, but it was too difficult. But I can set t of x equal to 0 and solve, and it's not going to be a problem at all. So that's what I'm going to do next. I'm going to cover some of this up so I actually have some space to write. I'm going to say, okay, let's set t of x equal to 0, which means -4x plus 11 equals 0. Totally easy to solve. -4x equals a minus 11. Divide by -4, divide by -4, and x equals positive, negative, and negative make a positive 11/4. That means that this root, the red dot right here, is crossing at negative or positive 11/4, about 11/4. So what I'm going to do is say, okay, right here is about 11/4. 11/4 is 2.75 as a decimal. X equals 2.75. I can do that in my head. So it's about 2.75 is where my root is. Now it's an approximation. So the whole entire goal was to figure out where g of x crosses. I'm saying it's going to be really, really close to the tangent. So it's really, really close to 2.75. That's my answer. And this, I'm going to write next to this, this is an approximation. Approximation. The real actual answer, you can go and check and verify if you have the luxury of using your calculator. If you're in a non-calculator section on an exam, then you'd probably be all done at this point. There's nothing else you can do. But since, you know, we're not taking a test right now, I want to jump on the calculator and, you know, take a look at this a little bit. So what I'm going to do, I'll put this under the screen. I'm going to graph g of x. So I'm going to graph in that equation. And g of x was 3 plus 2x squared minus x to the third. That's the graph. And I'm going to zoom, and I'm going to hit zoom number 6, Z standard, just to get a regular graph. Bam, there it is. Now if I want, I could put my tangent line on here too in a minute, but let's wait a second. Let's find this root using the calculator. See where it crosses? It's around 2.75, I think. So I'm going to go second calc, and I'm going to go down to a 0. 0 means root, and I'm going to enter. And it's going to ask me for a left bound, so I'll scroll around with my arrows here, and I want to be on the left side, so somewhere up here, and hit enter. And then I'm going to scroll down here to the right side, hit enter. It's going to say guess, so I hit enter again, and it says that my 0 is at 2.485584. Pretty dang close to our approximation, 2.485584. So not too far off. So I'm actually going to write this down just to have it. I'm going to say that using my calculator, so let's see, this underneath. This has gotten a little messy, but I'm going to say actual value, the actual value for the root is x equals 2.485. Copy that off my calculator, 3 decimal places. So here's my actual value, and then my approximation. My approximation is I ended up getting x equals 2.75. So not too far off from that. And then there's my 2 answers. If you're in a non-calculator section, you wouldn't get the actual value. You couldn't do it really. What this is all saying is if I could actually solve this one where I put the little thought bubble, if I could actually solve this and get an answer, x is going to equal this answer. So if I could actually figure it out. So that's kind of how you do an approximation. There's a lot of other types out there, but your homework for class has a couple that ask you about roots. So they're not talking about a square root, they're talking about x-intercepts. Roots are x-intercepts. So use this to kind of help you with the homework a little bit, and I'll see you guys in class.